stuff here is what we call a rock cleavage. And a structural geologist can interpret the planes of those lines, the planes of those plates, those diagonal surfaces, to determine the principal direction of compressional stress that caused this folding. All we need to know here is that it was caused by compression, folding always is, and the cause of the compression is coming from the east, from what is now east. Now there's a funny thing about the microstructures here, and if you move over to here, this fold over here, there's some wavy structures which are caused as original sedimentary structures. Some of them are due to deformation. And there's some little structures here, if we look carefully, they're called boudins, or sausages, in French. What happens is you get a sediment that doesn't want to deform. It doesn't deform easily. And then you get around it flowing a clayey sediment that's kind of plastic. And it forms a sausage-like thing, if I can draw it here. Sure. And these things, well, some of them may be boudins, some are sedimentary features. Let's see here if I can draw it for you real quickly. All right. This would be a boudin here. So I'm sure you've seen in butcher shops strings of sausages that they're just sausages that are strung together like a string, a chain. And you'll see some of these features in here. Again, the sausage part is sediment that doesn't deform easily, and then the stuff around it is the shaly sediment that when it's compressed, it does deform and it sort of flows around those sausages. But there's a complication here. Some of these features are mixed together with what may be original sedimentary features and other deformational features. And so some of it is clearer than others. So we can go over there, but we have to be really careful here. This is a really bad area here. The cars just come really close. So let me go over there and see if I can find some stuff for you to point out. Point it out to you if I don't get hit wrong.
Okay, while he's going over there, keep in mind this was a sedimentary rock. It was like a shale, okay? And think about how much weaker a mud rock is than something that's made out of quartz, something that's much harder. So if you're going to add compression, if you're going to push things together and you heat it up ever so slightly, what is going to happen is this is going to deform a lot easier. And so the reason we're having these folds is because this rock tends to bend, because it's weaker, more so than break. And so we're seeing the effects of that. And so this rock has been metamorphosed to a degree too. This is kind of a very low-grade metamorphic rock now. Probably what we would call a phyllite. So remember, we have slates representing the lowest grade, and now we're getting into some phyllites, okay? And so you're seeing those boudins that he was talking about. Remember, those are like the linked sausages. If you think about, you've got something solid. Oh, he's found something.
Hold on.
You got something that's solid and you're trying to stretch it, and it doesn't want to stretch. It breaks apart into little fragments, and that's kind of what boudins have. That's what they have happened to them. You've tried to stretch something, and I mean, when you bend something, you basically break it into different places if it's solids, and so you produce these little sausage-looking structures. Is that making sense? A little. not much.
Is the like why is there a compression as well as a stretching force?
Well, okay, when like this, I mean, you've got compression that causes the first amount of stress. Okay, but then as this stuff folds, okay, now you're trying to fold it, which takes up more room. So then you've got some stretching going on. Okay, so that's what's happening here, and so you're getting kind of both forces working. The big force is the compression, but within the rock, you're getting some stretching going on because you're trying to bend it around the corner, and there just isn't enough material, basically. Okay, so yeah, you need to go over and see these features.